Water is a critical component of water jet systems and is utilized in two very important and distinctive ways: process and cooling. Poor quality process or cooling water can have a significant negative impact on your machine, reducing component life and increasing the amount of maintenance required. Providing your machine with high quality water will increase its performance and operational life. The process water that supplies the intensifier pump that produces the ultra-high pressure water should be pre-treated for the removal of hardness, reduction of total dissolved solids, or regulation of pH level. Water softening is an ion exchange process that removes scale-forming minerals such as calcium. Total dissolved solids can be reduced with either deionizing or reverse osmosis equipment. TDS stands for total dissolved solids. Low TDS, less than 100 parts per million, is considered good water quality and can be treated by softening. Moderate TDS, 100 to 200 parts per million, can be treated either with softening or TDS reduction, reverse osmosis, or deionizing. High TDS, greater than 200 parts per million, is considered poor water quality and should be treated with reverse osmosis or deionization. High silica content greater than 15 parts per million can only be removed with reverse osmosis or deionizing systems. The cooling water the heat exchanger uses can be regular tap water to cool the hydraulic fluid. The hydraulic fluid temperature must be maintained below 120 degrees Fahrenheit. A constant flow of 3 to 12 gallons per minute is needed depending on the pump model. The incoming water temperature should not exceed 70 degrees Fahrenheit. The physical process of pressurizing the water within the intensifier cylinder causes a rapid rise in water temperature. The temperature of the water supplied to the intensifier assemblies should be kept below 70 degrees Fahrenheit. Excessive inlet water temperatures can cause accelerated wear and reduce component service life, especially to the high pressure seals. One, two, or three water filters, depending on the intensifier pump model, provide successive filtering of the incoming water. The incoming water is filtered by a 10 micron filter, followed by a 1 micron filter, and finally a half micron filter. The water filters should be replaced every 250 hours of machine operation. Some intensifier pump models have one water pressure gauge after the filters. It monitors the water pressure of the filtered water. Record the pressure with new filters when the pump is running. When the gauge pressure shows a 20 psi difference, change the filters. Some intensifier pump models have two water pressure gauges. One gauge monitors the input water pressure, the other gauge monitors the water pressure of the filtered water. If the water pressure varies by approximately 20 psi, the filters should be changed. Ensure the water supply is turned off and verify that the water pressure is 0. Unthread and remove a water filter canister. Remove and discard the filter element. Install a new water filter element in the canister. Thread the water filter canister into position and hand tighten. Turn the supply water on. Press the red bleed button on each filter head to expel any air. The water accumulator is a water chamber with an internal air bladder to dampen spikes in the low-pressure water system. The accumulator is factory set to 38 psi. It has an air fitting on the accumulator to check the pressure. The air fitting is also used to add air to the internal bladder. Remove the cap from the accumulator to access the air fitting. Use an air pressure gauge to check the air pressure of the accumulator bladder. It should be within 10% of 38 psi. If needed, add compressed air through the air fitting to set the pressure of the accumulator.